Hi there, I'm Johannes from Mercedes-Benz R&D in Sindelfingen, Germany. In my session about Azure Postgres security, I'll dive into details how you can make your database more secure, and I will focus about network security and access management. I'll cover all the basics and explain how it works together, so no prior knowledge is required. I want you to be ready to build your own solution in this space. See you in my session. Okay, let's stop intrusions in their tracks. If you look at security for Azure Postgres, there are different areas, like data protection, where you encrypt your data in transit and data at rest. Then you can do row-level security, where you ensure that certain rows of a table can only be accessed by certain users. Then there's Microsoft Defender for Cloud as an overall security management and threat protection solution. But two key aspects where you can make a lot of difference is network security and access management. And I would like to focus on these two areas now in this session because this is really where I can have a big impact by your configurations. Okay, network security is the first topic. Basically, there are two fundamental ways to set up your network for Azure Postgres: private access and public access. With private access, your Postgres server is integrated in a virtual network. With public access, it is accessible from everybody on the public internet. In either way, you have authentication that the application needs to perform when connecting to the database. Then the network traffic is always encrypted using TLS. The Postgres server has a domain name, and there are authorization rules that control like who can access which tables and which databases. But let's start with looking at public access. So with that, as the name suggests, there's a public endpoint, so it is publicly resolvable via DNS. But still, it doesn't mean that everybody can connect to the database. Usually you set up some firewall rules that control then the range of IP addresses that are allowed to access the server. The Postgres server is not part of any VNet, and this then means that the traffic goes over the public internet pathways, so that's not secure. Here on this page in the Azure portal, you see kind of how you can configure firewall rules, where you can, for example, specify IP ranges from the egress of your Kubernetes cluster if you run the application in Kubernetes. So this fits quite well. In the middle of the screen, there's this checkbox where you can allow public access from any Azure resource, but usually you wouldn't set this because any unrelated Azure service could then connect to your databases, but you would not like typically. You don't have to configure these rules manually. You can use tools like Terraform or other infrastructure as code platforms to configure your firewall rules like this. But overall, it's not that safe because it's the Postgres server is vulnerable to external attacks, and the traffic travels over public internet, so it can be sniffed. The other way is private access, and so the Postgres server is injected into an Azure VNet, as shown on the right-hand side here in this diagram. One big benefit is that the network traffic travels over the Azure backbone, so not the public internet. You should be aware of that the VNet needs to be in the same Azure region, and you need a delegated subnet for all your Postgres servers in this VNet, but this is okay. It can be that the application is in a different VNet or in a different region, and then you would use like VNet peering to connect these virtual networks so that the application can reach the database. As the Postgres server is not accessible from public internet, you need a private DNS server like Azure Private DNS for the domain name resolution. Here you can see a page from the Azure portal about like the network setup, and at the top you see kind of network connectivity, these two base methods, public and private. And you need to be aware of that you can configure this only during the initial provisioning of your Postgres server. So that means when you have selected either or the other one, then that's it. You cannot change it anymore. And also the VNet that is then specified here for the private access case cannot be changed. So if you set this up initially, then that's it for the lifetime of this Postgres server. You can automate all of these steps, like here again with Terraform as an example, where you configure and you provision your VNet, specifying the address space that should be used. Then you delegate a subnet for the Postgres server. Then you have your private DNS zone that is needed. And finally, you connect the private DNS zone with the virtual network using a virtual network link. So that's it. It can all be automated. But looking at this, I mean, there's some big benefits, of course, because it's like better secured, better restricted. But a VNet is restricted to one Azure region, and you can create your network architecture with multiple VNets, but this can become complex. And also with VNet peering, you need really to trust the resources in the other VNets, because the network security group rules that you can configure, they work quite low level at like IP or port level, and so it's hard to set up data exfiltration rules that really work well. Also, as I indicated, the Postgres server cannot be reassigned to another VNet. Okay, so now the latest addition here in this space is then Private Endpoint, and this is basically a variation of the public access connectivity method that I described earlier. It is a recent enhancement. It was introduced in February 2024, and it is supported for all Azure Postgres servers that were created after this time. So not for the older ones, but for all the Postgres servers that were initially deployed after February 2024, you can use it. What does it do? It adds a network interface to the resource, and this provides then the resources in the VNet or private IP address for the Postgres server to connect. The network traffic travels securely over the Azure backbone, and one consideration is also that there are some additional costs that are then charged for the private endpoint. Here in the Azure portal, you can see, like at the top, that's the basic connectivity method. It's public, but here you can at the same time dynamically enable and disable this public access. So, and this is quite useful, for example, in migration scenarios where you used to have public access enabled for your server, but you would like to introduce private endpoint, then you can still allow public access for some time and then add your private endpoint until you're set up, and then later you can disable the public access. At the bottom, you see the private endpoints. You can have multiple private endpoints. So for each VNet that should connect to your Postgres server, you can have one. And the VNets can also be in other regions, so there's no restriction there. So that's quite, attractive, I think. You can provision the private endpoint also using like infrastructure as code with Terraform. You provide a name, you specify kind of the VNet and the subnet that it is connected to. And for that, it is important they are deployed in the same Azure region as the VNet. And then you specify as a resource your Postgres server. And here, this one parameter is manual, is approval needed. And yeah, and this is what you can configure, and this can be useful if you configure a private endpoint like for another resource. Okay, so now if you have set up all of this, there's some operational aspects. So if you used to connect to your Postgres server using public access and you have disabled this, then okay, you can also don't access your Postgres server from your local machine anymore, which may be useful like for troubleshooting purposes or for similar tasks. But there are alternatives. You can use pgadmin or some other tool within the VNet. There's some documentation how you can set this up. An alternative way that I personally like is like Azure Bastion, where you dynamically kind of enable a virtual connection using shell or remote desktop. And I think this works quite well if you only want to run a few queries for like select statements for troubleshooting. This works quite well. Also, the costs are then not an issue, because you would run this only sporadically when needed, and then tear it down again. If you want to check out, okay, I have my Postgres server, does it really have a private endpoint active? Then you can use tools like, or commands like nslookup or dig, where you then find under canonical name whether private link is part of that name, and if so, then a private endpoint has been enabled. Now, it can happen that for some reason a private endpoint does not work anymore, which is not good. But then it can be sometimes tricky to find out what's the matter with it, and how can you uh, analyze the situation. And one thing to remember is that as long as the private endpoint exists, the connections from within a VNet for the private endpoint, they try to use it. And so even though, for example, you have enabled public access, and the public access from outside of the VNet works perfectly fine, it still may not work from your private endpoint because it's in this VNet. And so also testing from outside of the VNet does not help really because it's not realistic. So to analyze, you would have to get into the VNet, like using Azure Bastion or some other way, and then you can try out whether it still works, or you can do some analysis. If you have enabled public access, for example, or as a last remedy, you can also then drop the private endpoint and recreate it. So that's really kind of maybe also some good benefit. I mean, it's really flexible, and if for some reason it does not work anymore, you can recreate it, and then it should be fine again. So to summarize, so there are some considerations for private endpoints. So they look at the granularity of individual Postgres server instances. So not at the service level itself, but really for each instance you can enable the private endpoint. You have explicit control also at the resource level. You can allow or disallow a VNet for a specific, a private endpoint for a specific VNet. So that's also good. Traffic travels over the Azure backbone. That's a benefit. Also, like maybe compared to private access, the data exfiltration protection is inbuilt. So that's, I think, also quite attractive. You are better here with that regard. You can flexibly provision or deprovision the private endpoints. It's not like with private access, you have the VNet and that's it. So it's really more dynamic. And maybe the downside, there are additional costs. And also, if an existing Azure Postgres server uses private access today, then you cannot enable private endpoint in addition. You would first have to migrate the data to a new Postgres server with public access, and then you can enable private endpoints and benefit from that. Okay, so that was about network security. Let's move on to access management. And this typically consists of two parts, authentication and authorization. With authentication, you verify the identity of your application or your user, and authorization checks are performed to check the permission of or for an intended action. So does the application really have the permission to do some action in the database? Okay, so for authentication, like the traditional Postgres way using user and password works fine. I mean, they are stored in Postgres. It's up to you, though, to manage these users and passwords. So if you would like to rotate a password, for example, then this is your task, and it's not so easy because there's only a single password for a user. So this is like manual overhead, administrative overhead that you need to take care of. The other way is Entra authentication. So the standard, like Microsoft Azure way, or Active Directory is the formal name. And here you have as a benefit the uniform management of users. So you can use these users not just for Azure Postgres, but also for all the other Azure resources and resource types that are available. You can rely on Entra group so that you treat all the users from a group the same way. And you can combine this with password, so that you provide a password, or which is more appealing, is passwordless. So really, you don't have to worry about passwords anymore. This is all handled by Azure, and I will talk about this in a little moment. Maybe just first have a quick look at Azure Portal again, how it looks like there. Here on the authentication page, you can configure whether your Azure Postgres server is supposed to support Postgres authentication, Entra authentication, or both. And the last option is probably attractive also as earlier for migration scenarios where you used to have a Postgres user but would like to introduce Entra authentication, then you can enable both of it for some time. At the bottom, you see the Entra administrators that have been created for the server, and this is also maybe a little different compared to the Postgres way because for the Postgres authentication, it's only one admin user, and here for the Entra way, you can have multiple of them. Okay, so let's take a closer look at the passwordless connection. And here you can see at a high level how it works. So the application does not provide a password anymore when connecting to the database, but rather the application is associated with an entity in Azure Entra, so the managed identity that we'll talk about. And then when the application connects, it provides a token internally, and then Postgres can check with Entra, okay, does this token belong to the application, and is it valid? And if so, then the connection and the access is granted. How can you enable this? And there are a number of steps to enable this, but it's not a big deal. It's just a number of steps because different areas are involved, and that's why it takes, these steps to get to the full solution. But you can automate all of them using Terraform or some other way. And now in this example, I will talk about AKS clusters or Azure Kubernetes service with an application using Spring Boot, but that's maybe an attractive combination. But there are also other app platforms like Azure Functions or Azure App Service, and they are also supported. But now let's take a look at this combination here with AKS cluster and the Spring Boot application. So the first step is to provision a managed identity. You basically provide a name, and this is then a user-assigned identity. Okay, that's it. So the identity exists. As a second step, you enable managed identity, and here it is called workload identity at the Kubernetes cluster level. You also need to enable that it can serve as an OIDC issuer, but that's basically it. Then the more interesting part is the third step, where you create a federated identity credential. And here you basically correlate the managed identity with some workload in the cluster. So here under parent ID, that's the ID of the managed identity that you created earlier. Then issuer is the OIDC issue from Kubernetes cluster. And then under subject, there are two portions of this parameter. One is the namespace, so that's the namespace name in the Kubernetes cluster, and the other piece is a service account. And the service account represents your service in the AKS namespace. So it's really specific. It doesn't mean that you enable kind of the whole Kubernetes cluster with your managed identity, and then any application running in the cluster could connect to your Postgres database claiming the managed identity. So that's not the case, which is good. So it's really specific, and you can say, okay, for this one microservice or application, I enable the managed identity, and then only this microservice is allowed to connect using the managed identity. Then in Postgres, you also need to enable this. What we saw earlier in the Azure portal, you can also configure this. And don't be confused by the naming. It's just the older name of Entra, which is Active Directory. So you enable this here, and also then you can provision the Active Directory administrator, so the Entra administrator, in new naming. Then we need to enable the the managed identity or workload identity also for your specific service account and pod. So there's a parameter called workload or Azure workload identity use. And here for service account and the pod spec, you would have to set it. And what is also key, there's one annotation where you specify your client ID of the managed identity. And so it's really then kind of this combination is then fixed for the combination from the managed identity with your service. And then last but not least, for your Spring Boot application, there are 2 steps. It's more like configuration steps. You don't have to change kind of the coding. One is to add a dependency to the Spring Cloud Azure Starter JDBC PostgreSQL library. That's a long name. So you add this dependency, okay, and then in the application properties of your application, you first specify the Entra name, so the name of the managed identity under username, and the other setting is then Spring.source Azure Passwordless enabled, and so that means, okay, no password is provided by the application, it's just passwordless, and the rest is taken care of by Azure and the Azure lib. Okay, now if you have set this up, does it work? Okay, so usually you find out quite soon if it does not work, because then your application cannot connect to the database anymore. I mean, that's usually what you then see and feel immediately. And if it works, then okay, in the deployment log, there are messages like this saying, okay, the Azure AKS token exchange has happened, and that's it, and then it works fine. So okay, so that's it. Now we have authenticated successfully to the database without password, which is good. You don't have to manage your password anymore. But now, which permissions exist in the database for my application? Now let's talk about authorization. And what is quite well known is this principle of least privilege. So I would like my application to have as few permissions in Postgres as possible, because then the chances are better that no harm can be done by whatever reason. So I would like really the application only to do these steps that are absolutely necessary, but nothing else. One way to accomplish this is to set up my pipeline that creates or that deploys my service. And here there are 2 examples where I define a service connection, like in Azure DevOps, but also like you can also use other tools, other CI/CD pipelines, where you correlate a managed identity with appropriate permissions in Azure Postgres with this service connection. On the right-hand side, you see a way to set up a VM scale set in Azure and correlate your managed identity with this VM scale set, and then you can use this VM scale set as a runner or as a self-hosted agent in Azure DevOps. So that means here for this connection for your CI/CD pipeline, you have a managed identity, and then if the pipeline is executed, then you can do stuff as I show it here on this slide. So in this example, it's a flywheel script that takes care about managing the database objects, about like creating tables, updating table layout, adding columns, and similar tasks. And here, to use the managed identity that was associated with this pipeline, you just say like AZ login identity and then provide the the ID of the managed identity. And that's it. I mean, no password needs to be specified, but kind of this connection to the managed identity is baked in using the pipeline definition as I showed earlier. Then you don't have a password, but tools like Flywheel delete a password. And so what can you do? You can generate a token, and here with the AZ account get access token command for the OSS RDBMS resource, or the database resource, you can generate an appropriate access token, pass it in for your password, and then run the Flywheel script. So that's it. Then that means all your objects have been created. And now, kind of one key part, I would like to have a new role that is only allowed to access these tables, like to insert data, to read data, but not to do anything else, not to create additional tables or stuff like that. And so I can then create a new role in Postgres that is correlated with a new managed identity. So now we have a second managed identity. Like here, you see that's a function in Azure provided specifically for this task called create principal with OID. And here you would specify kind of the name of the role, which can be kind of this new Entra service name, the object ID of the managed identity as it exists in Entra, and some additional parameters where you can say, okay, should this be a regular user or an admin user? But then basically you have in Postgres a role that correlates to your Entra user. Okay, and now since you have this role in Postgres, then you can grant the permissions that you would like it to have, like grant usage on schema public, or grant like all the DML statements like select, insert, update. So that's needed. So that's fine if we pass these, or if we grant these permissions, but no DDL operations should be allowed. And so we will only grant then the DML statements. Okay. An alternative way, if you already have a role in Azure Postgres, is to assign a security label, and that's also a similar idea. You correlate then kind of this existing role with your Entra service ID. Okay, or with the managed identity, which is here represented by the object ID. Okay. Now a few operational aspects. So one is, okay, I would like to connect using Entra ID in my DBA tool, like pgadmin or dbeaver. And as I showed earlier, also for this case, you can generate an access token and then log into your DBA tool. But here it's only important that as a user ID, you have to enter the Entra name exactly as given or as shown here in Azure Portal, and then the token as a password, and then that's fine. Then it should work. And then, yeah, maybe just a minor thing, but it can be confusing if you execute a grant statement that grants permissions to a certain user. This typically always succeeds, so no error. Even though, for example, if you try to grant a permission that you don't have actually, so then you're not able to grant this permission to another user or to a managed identity, but still the grant statement will succeed and looks like everything is fine. But here, I mean, if you are in doubt, you can check here under information schema, role table grants, and then you find out everything that is provided and has been made available with regards to permissions for this user. Okay, to summarize, we talked about private endpoints, which provide a new network opportunity for Azure Postgres. There are additional costs, but it's more flexible, more dynamic. And then the other big topic is passwordless connection. And once you have set it up, then Azure takes good care of all the details. You don't have to manage your passwords anymore. Also, they cannot be leaked anymore accidentally because you don't have a password. So everything is done by Azure for you. So it's basically the ultimate solution for password management. Okay, so that's it. So with that, I would like to thank you and conclude my session.